Hello and welcome to the first video in Lesson 5 for Module 3. Today we're going to be looking at completing the square. If you don't already, please make sure you get your notes out in front of you, your student notes that your teacher should have provided you in a PDF form or maybe a printed form too. So we're going to look at completing the square. So before we get into what completing the square is, let's go ahead and get into this opening exercise here that the directions are asking us to do. So we're asked here to rewrite the following perfect square quadratic expressions in standard form, and then look for patterns in the coefficients and write 2 sentences describing what you notice. Okay, we'll write the sentences maybe down here or something like that. Okay, so there's the factored form, x plus 1 squared. So this is a perfect square. Why? Because you're taking something and you're squaring it, right? So that creates a perfect square. Just like if we take 3 and square it, we get 9, and 9 is a perfect square. Or if we take 4 and square it, and we get 16, and 16 is a perfect square, we can do the same thing with these polynomials too. If we square a binomial, then the result is also a perfect square polynomial. So it's going to look like this. X plus 1 times x plus 1 for the factors. Then we'll distribute it. So x times 1 will be x squared plus 1x, and then 1 times 1 will be 1x plus 1. And when we combine like terms, we'll get x squared plus 2x plus 1. All right, let's try the next one. So the next one here, we have x plus 2 squared, so x plus 2 squared, x plus 2 times x plus 2. Again, distribute it out, so it'll be x squared, x times 2, so another 2x, 2 times x, so another 2x, and 2 times 2, so that's a 4. Again, combining like terms here, we get x squared plus 4x plus 4. Okay, go ahead and try the rest of these. Pause the video and do the rest of them here. Okay, hopefully you pause the video here. I'll go ahead and just do the rest. 3x plus 9, and so you get x squared plus 6x plus 9. This next one is x plus 4 times x plus 4, which will be x squared plus 4x plus 4x plus 16, which will be x squared plus 8x plus 16. And then x plus 5 squared will be x plus 5 times x plus 5, which will give us x squared plus 5x plus 5x plus 25. Again, just using that distributed property and combining like terms gives us x squared plus 10x plus 25. And then finally, x plus 20 times x plus 20, which will be x squared plus 20x plus 400. Combining like terms gives us x squared plus 40x plus 400. Okay, so what are some patterns we see here from the factored form to the standard form when we expand it out? When we expand out that polynomial, what do you see happening? Okay, well, if you look here, all of the constant terms, the 1, the 4, the 9, the 16, the 25, and the 400, they're all the squares of 1, 2, 3, 4, 5, and 20. Okay, so the constant term, or C, is the square of the number in the binomial. Okay, what about the middle term? Okay, the middle term here, we get 2, then 4, then 6, then 8, then 10, then 40. Okay, so how do those relate? Well, 1 to 2, 2 to 4, 3 to 6, 4 to 8, 5 to 10, 20 to 40. What's happening here? The b term is double the number in the binomial. Okay, so double these numbers and you get all these b terms. Square these numbers and you get all these c terms over here. Now try working backwards. rewrite the following standard form quadratic expressions as perfect squares. So we're already told that all of these here are perfect squares. Now we just need to write their factored form. So let's work backwards. Okay, so again, here we see that 36 is our C term. Remember that all these C terms here, they were perfect squares of our original numbers here. So what squared gives you 36? The answer is 6. Okay, and that matches up here with a 12 because half that 12 also gives you 6. Okay, which again, half of 8 gives you that 4. Half of 6 gives you that 3, right? Half of 10 gives you 5, right? So you can see how they all match up there. Okay, so it's going to be just x plus 6 times x plus 6, or x plus 6 quantity squared. Okay, what about this one? We still have the positive 36, but now we have a negative 12. How should we fix this? Well, instead of x plus 6, we can x minus 6, or x minus 6 quantity squared. Okay, what about this one? Well, what squared gives you 100? 10, right? And then double that gives you 20, so yep, it's x plus 10 times x plus 10. Again, or we could just write x plus 10 squared. Ooh, what about this one? What squared gives you 9/4? Well, 3 halves, right? If you square root 9, it's 3. If you square root 4, it's 2. So this is just really 3 squared over 2 squared. So in other words, just 3 halves. So this will be x plus 3 halves. But we have a minus 3 here. So if we double this, it doesn't give us a negative 3, it gives us a positive 3. So we want this 3 halves to actually be a minus 3 halves. Again, or x minus 3 halves squared. Okay, go ahead and try this one. What would it factor to be? Well, what two numbers that are the same multiplied to 2,500? The answer is 50. And if you add those two 50s, there you go, you get that 100. That would be right in there. Okay, so again, or x plus 50 squared. Now how about this one? Is 3 a perfect square? It isn't, right? So what do we do here? Because 3 is not a perfect square, how do we do this? All of these were perfect squares. Well, maybe we can try looking at the middle term here, right? Remember, all these middle terms, if we did half of them, that's what gave us our numbers too, right? So like half of 12 was 6, half of negative 12 was negative 6, half of 20 was 10. What's half of 8? 4. So could we just write x plus 4 and x plus 4? Well, that would give us the 8, but then 4 times 4 is not going to give us the 3 there. It gives us 16. So what do we do here? Well, we'll do that in the next video.